Hi, my name is Jessica Antee, and this is my Artifact 1. Standard 1.1 ISTE Criterion 2, Set Professional Learning Goals, and Standard 4.2 ISTE Criterion 13, Co-Learn with Students about a new digital tool. Standard 1.1 Criterion 2, Set Professional Goals. The first goal I set was to incorporate technology to enhance STEM education in my K-5 STEM lab. The second goal is to build a professional learning network to learn more about using technology in the classroom. Here are some pictures of my students when we incorporated more technology to enhance the STEM education in the STEM lab. I incorporated tools for presentations, including Google Slides, Canva, and Weebly. Those tools can also be used as collaboratively along with Flip. We use Scratch for coding, as well as SpheroBolt, Ozobot, and Bbots that also included robotics. Tinkercad was used to design items that would be 3D printed by one of the two 3D printers in the Innovation Lab. Goal 2, build a professional learning network to learn more about using technology in the classroom. I started by following EdTech leaders and groups of educators on social media. Then I joined ISTE to learn best practices for integrating technology into the classroom. I was able to attend ISTE Live 2022 in New Orleans and STEMpalooza in Cobb County. I learned so much and was inspired by both conferences. Standard 4.2 Criterion 13, Co-Learn about a new digital tool. Our assignment was to create a program of code to make the SpheroBolt robot move in a square pattern. SpheroBolt used an elementary appropriate block coding format. Co-learning with SpheroBolt. We began the lesson with a discussion of the objective. I showed the students how to log in using the ViewSonic board. Then we watched tutorial videos and used the Sphero lessons to walk us through step by step. The students worked in small groups to complete the lesson. Some students were able to catch on more quickly than others, leading to student-led learning. Through this co-learning experience, students had successes and challenges. Some of the student successes were with the coding and editing of the code. Students caught on quickly how to manipulate the program. Students worked well in small groups and helped each other troubleshoot throughout the lesson. Some students were able to complete the assignment and go beyond by adding lights, sounds, and other features to the program. The first challenge that we had was logging in. Students had to type in their first name and last initial. Many students didn't know what initials meant, so they were very frustrated when it would not allow them to type their whole name. Students also had to join our class by typing in a 6-digit code. To be able to program the robot into a square pattern, the students needed an understanding of angles. Some students struggled with that, but with added support, they were able to get through it. Connecting the iPads to a specific SpheroBolt was also difficult. As the teacher, I also had successes and challenges with this experience. The successes included students were working in their groups independently, using the help of their peers and the step-by-step Sphero tutorial. Learning the platform together provided maximum engagement as students were racing to be able to teach me something new. Learning the platform with the students was challenging for me. I wanted to have all of the answers for the students immediately. Connectivity was also an issue. I didn't realize that the iPads were going to try to connect with all of the SpheroBolts in the room. It took the students and I some time to figure out that you must hold your bolt close to the iPad to connect.